these questions, you're given a function f, and then you're asked to implement the functions using a 4-bit active low decoder and AND gates. And question 2 asks you to implement it using 4 bits active high decoder and OR gates. So in questions like this, we're going to write down the truth table. So we start off with listing all the possible combinations. So we have A, B, C, D. That's all the possibility of A, B, C, and D. So it's going from 1, counting up to 15 in binary. Next, we're going to list down all the inverted Boolean variable. So we have A is inverted, B and C is inverted. So we're going to have A bar here, B bar and C bar. Then we're going to list down all the products. So we have A, D. So A and D is 1, give you 1. So A, D is 1, give you 1. So the rest will be 0. Then we have A bar, B, C. So meaning is that A bar, B and C is 1, going to give us a 1. So A bar, B and C. So we got A bar, B, C. Give us 1. A bar, B, C. Give us 1. And then the last products term is B bar, C bar, and D. So B bar, C bar, and D give us a 1. Then we have B bar, C bar, and D give us a 1. Then we all the product terms together, meaning that either one of them is 1, gonna give us a 1. So we got a 1 here, 1 here, and here, 1 here, 1, 1, 1. So that is the truth table for our function f. Then we're going to implement this using a decoder. So if we write down our sum of products of this function f, so we have here's our min terms, m1, 0, 1, 2, 3, 4, 5, 6. This is m6, m7, 8, m9, 10, m11, 12, m13, and then m15. So this will be a sum of 1, 6, 7, 9, 11, 13, and 15. And the first question, I'm going to implement it using an active low decoder, meaning that the output is 0 when it's active. So meaning that to implement this, we're going to do a De Morgan's of this. So to make this into products of sum, be 0, 2, 3, 4, 5, 8, 10, 12, and 14. And that will be our max term. So that will be our max term here, m0, m2, and so forth. So this is in fact is a product of sum. So this will be our max terms, m0 plus so it's not plus, it's a sum. The products of sum. So it's a product which is an n function. So to implement this using a decoder, so we're going to use AND gate. So here's our max term M0, and this is our max term M2. And then this is our max term M3 and M4. Then M5, M8, then M10, M12, and M14. Then we can end this together. And then we can end this to our M14. That will be our function f. For question 2, if we're going to implement this using active high, so we're going to use OR gate. So let me rewrite that function f in sum of products. That will be the sum 1, 6, 7, 9, 11, 13, and 15. So if it's an active high decoder, the output will be our min terms. In active low, the outputs will be our max terms. So these are M1, M6, M7, M9, M11, M13, then M15. So that's the Same functions, but implemented using an active high decoder.